Hello everyone. In this video we'll start with the idea of adsorption. So in surface chemistry chapter basically we'll have three important segments. One is the idea of adsorption and the properties of adsorption and concepts related to that. Then we'll have applications of adsorption. One in terms of the catalysis, heterogeneous catalysis, and the second one will be the colloidal solutions. So mostly if you look at the recent years, we are getting questions from in competitive examinations, of course, we get questions from the colloidal solutions and catalysis. But here we will get a lot of basics in terms of what is adsorption and how this phenomena will be able to result in the behavior of catalysis as well as the colloids. First, to begin with the idea of adsorption. The surface of a solid has a tendency to attract and retain molecules of the phase with which it comes into contact. So this is what we are looking at as the adsorption. So if we have a surface of a solid and it is coming into contact with say a gaseous medium, then what is observed is the particles of the gas are coming and getting accumulated on the surface of the solid. Thereby we will see that the concentration of the gas particles is more on the surface of the solid. Similarly, we can also have a liquid solution where we have a solute which is dissolved in the solvent, which if it is coming in contact with the solid surface, then again in this case also we will see that the solute particles are coming and they are getting attracted towards the surface of the solid, and they are also being retained on the surface of the solid. So we'll see that the concentration of the solute particles on the solid surface is increasing over a period of time. Not only these two, we also have the adsorption in the case of the liquid surface. So if you have a liquid surface, then if it is coming into contact with the gas, then the liquid surface also can attract and retain the gas particles. So in this case we will see that the concentration of gas particles is more on the surface of the liquid. So broadly this is what we look at as the idea of adsorption, and this is observed as a common phenomena and also used for particular applications. Like if you look at the method to create vacuum. So generally if you look at the air in a room, we have majorly oxygen, nitrogen, and along with there will be the gases. So most of these gases like oxygen, hydrogen, carbon monoxide, chlorine, ammonia, SO2, if you take them in a closed vessel containing powdered charcoal, so this substance has got it will be in the solid form. It has got the property to attract and retain these gases on its surface. What we observe is after some time the pressure of the gas in the enclosed vessel will decrease. So why the pressure is decreasing is basically because the gas particles are getting adsorbed. The molecules they concentrate on the surface of the charcoal, and what we say is these gases are getting adsorbed on the surface. So this way if we keep doing then we will be able to see that we can create a really high vacuum environment. Now the other common observation is if you look at most of these organic dyes, they'll have a particular coloring pigment. Even if you look at something like as common as methylene blue, if the animal charcoal is added to the particular solution and if we shake it well, then what we see is the entire filtrate will turn colorless. Now, animal charcoal is a substance that is used very often to remove the color of the organic dyes. Now what essentially is happening when we shake it is the molecules of the dye, they are accumulating on the surface of the animal charcoal, and this is also a case of the adsorption. Not only that, if we have the aqueous solution of raw sugar, this is a common thing that we'll observe when we go and look at the street vendors who are selling the sugarcane juice, that is nothing but the aqueous solution of raw sugar. You'll see that it will be brown in color. But if the same sugarcane juice you happen to drink from a fine restaurant, etc., we will see that it will be colorless. So what essentially they are doing is removing the color. So if you take the aqueous solution of raw sugar and pass it over beds of animal charcoal, so we'll see what is making animal charcoal very effective to remove the color of these organic dye and organic substances when we talk about the properties of the adsorption. But here we see that in most of these cases we are using this animal charcoal. And by the way, animal charcoal is obtained by charring the parts of the animal bodies. So we char it so that it will become a very porous substance. Now the raw sugar juice is becoming colorless because the coloring pigment or coloring substances are being adsorbed by the charcoal. And even we see that the silica gel is effective in creating a dry environment, because if you have a silica gel, then it will be able to remove the water molecules from the air, and thereby we will be able to create a dry environment. So what happens there is the water vapor molecules are getting adsorbed on the surface of the silica gel. So these are some of the common observations which we will see, and even applications of the idea of adsorption. Now if we have to define the idea of adsorption, it is defined as a spontaneous accumulation of molecular species at the surface rather than in the bulk of a solid or liquid. Now here the reason why we are using these particular words is because first the idea of spontaneous. So the adsorption is a spontaneous process. It happens on its own, and the accumulation is happening at the surface rather than in the bulk of the solid or the liquid. So if it is happening, if the accumulation is happening in the bulk of the solid or liquid, we are going to be calling it as absorption. So that is a different phenomena where the particles of one substance will get into the other substance and uniformly distributed. So that is what we call as the absorption. So the adsorption is a surface phenomena, and the reason for this adsorption is unbalanced force of attraction or free valencies. If you look at these metals acting as the surface, platinum or palladium or nickel, transition metals especially, they do have the free valencies, and that's one of the reasons why they will be able to provide the surface and create easily the adsorption phenomena. So the two main reasons for the adsorption to happen are, one is in terms of the unbalanced force of attraction, second is free valencies. Now the molecules of a gas or a dissolved substance, they will come and settle onto the surfaces with which they come in contact because of these two phenomena. So if we have solid, we can have two possible cases of adsorption. One is gas can come and get adsorbed. This could be because of either the unbalanced forces, there is more force towards the surface of the solid, and the second possibility is if it comes in contact with the solution, the solute particles can get adsorbed. On the surface of the liquid, we can see the gas particles getting adsorbed. So the two reasons are because of the unbalanced force of attraction or the free valencies. Now we will see after some time that these free valencies will result in a type of adsorption called as chemical adsorption. So we'll talk about that as we go into the types of adsorption. But this is mainly the reason for the adsorption to happen. And if you look at what are the important characteristics of adsorption, now as such the phenomena is referring to the existence of high concentration of any particular component at the surface of a liquid or a solid phase. So we'll see that if a gas is coming into contact with a solid, or a liquid solution is coming into contact with a solid, the particles of the gas or particles of solute, they get accumulated on the surface of the solid, thereby the concentration of these particles will be high on the surface. Same way, if a gas is coming into contact with the liquid surface, the concentration of gas particles is also becoming high at the liquid surface. So the first important characteristics is the concentration becoming higher at the surface, and this is a spontaneous process. In thermodynamics, we study that any spontaneous process, the free energy change delta G for the process should be negative. So adsorption is accompanied by a decrease in the free energy of the system, and the reason why it is spontaneous is because of this. And if you look at adsorption, it is in a way like a condensation. Why we have say for example the particles of the gas, they are coming and getting accumulated on the surface of the solid. It is more like a condensation. So condensation is going to be an heat liberating process, or it is a process which is going to be accompanied by the evolution of heat, and hence we will see that these adsorption processes they will be having enthalpy change in negative. Now in some cases it will be more negative, in some cases it will be less negative, but nevertheless for all the adsorption the enthalpy change delta H is going to be negative, because we will see that this is more like condensation. And in terms of the entropy, if the gas particles are coming and settling on surface of the solid, or even let's say for example solute particles are coming and settling on surface of solid, this is resulting in a decrease in the entropy of either the gas or the solute particles, because when they are in the gas medium the entropy is more, randomness is more, but when they are coming and getting accumulated the entropy is actually decreasing. So thereby the delta S for the adsorption process will be negative. So we'll see that all the three thermodynamic properties, delta G will be negative, delta H will be negative, delta S also will be negative. So this is about the characteristics of the adsorption process. Now the key terms related to the adsorption. So we have been saying that there is a surface on which the adsorption is happening and there are particles which are getting adsorbed. So the substance which gets adsorbed on any surface is called as adsorbate. So here the gas particles or the solute particles, we are going to be calling them as adsorbate. So if you look at as an example, if a gas is getting adsorbed on the surface of the solid, then we are going to be calling the gas as the adsorbate. It is, I mean, in case of solution formation, we have solute and solvent. So this is more like the adsorbate is more like the solute. And the substance on the surface of which this is happening, this adsorption is happening, we will call it as adsorbent. This is more like a solvent. So we have adsorbate and adsorbent. So adsorbent is the surface on which the process is happening. Then adsorption, just like evaporation and condensation, we have the forward and the backward process. In most of the physical as well as the chemical process, we have both forward as well as the reverse process. The reverse process of adsorption is called as desorption. So desorption is the removal of adsorbed substance from a surface is what we call as a desorption. So if the adsorption is the forward, desorption is the reverse process. Then sometimes what happens is if you have a surface and there is another medium which is coming into contact with the surface, the particles of that medium will be settling on the surface and also they will be getting into the substance. So both adsorption and absorption will happen simultaneously. So if that is occurring, then generally if both of them are happening simultaneously, then we will call the phenomena as sorption. So sorption refers to the phenomena where we are having both adsorption as well as absorption happening simultaneously. Then particularly if you have gas getting adsorbed on the surface of metals, so this is important for us when we talk about the catalysis also. So this phenomena is generally called as occlusion. So occlusion is nothing but the adsorption of gases that occur on the surface of the metals. Now we have discussed about how adsorption is different from the absorption. Like we talked about various examples of adsorption. Absorption, to give you basic idea, if you have a sponge, duster made up of sponge, we just dip it into water, then what we essentially see is the water is getting absorbed. So in the entire sponge material we will see that the water molecule will be getting uniformly spread. So this is absorption, which is fundamentally different from the adsorption. We are most familiar with the absorption concept, and in this chapter we are exploring the adsorption. So adsorption is a surface phenomena, whereas the absorption happens throughout the whole mass of the substance or the adsorbent. Now the particles are retained only on the surface and does not get into the bulk or the interior of the solid or the liquid. So in case of the adsorption, whereas in the case of absorption, we'll see that the particles of the substance will get uniformly distributed throughout the body of the solid or the liquid. So they will not only be limited to the surface, they will get into the bulk of the solid or the liquid. And generally the adsorption will go through the equilibrium, because there is a forward and reverse process. So you'll see that initially the adsorption is going to be rapid, and then it will slow down to reach the equilibrium. So adsorption will be reaching the equilibrium stage. So once we said for the adsorption del G is negative, but even adsorption when it is reaching an equilibrium stage, del G will be equal to 0. So when the adsorption is happening, delta G will be negative because it will be happening spontaneously. But as it reaches equilibrium, delta G will become 0. And absorption generally will happen at a uniform rate. So we talked about the examples of the adsorption, like water vapors, they get adsorbed on the surface of the silica gel, and ammonia, even other gases like O2, SO2, they get adsorbed on the surface of the charcoal. Whereas if you see calcium chloride, which is an hygroscopic substance, it will be able to absorb the water molecules. On it, CaCl2 will be able to absorb the water vapors or water molecules from the atmosphere. Similarly, the ammonia is absorbed in water, and when ammonia is absorbed in water, it will get into the water and it will form ammonium hydroxide, NH4OH. So these are the examples of the absorption. And one common example of absorption is the one that we normally see. Like you take a sponge and then put it into water, we'll see that the water is getting absorbed by the sponge. So this is in terms of the fundamental difference between the adsorption and the absorption. Now we have said that we have different types of adsorption, and we can classify the adsorption into different ways, but here we are going to be looking at the reason for the adsorption as the criteria, and we divide the adsorption into two categories. One is physical adsorption, also called as physisorption, and second is chemical adsorption, also called as chemisorption. So what is this criteria and how are we going to do the classification? So if the accumulation of particles on surface of a solid or liquid occurs on account of the weak van der Waals forces, then that type of adsorption we are going to be calling it as the physical adsorption or physisorption. So physisorption happens because of the weak van der Waals forces. Whereas if the molecules or atoms are held to the surface of a solid by a chemical bond, so chemical bond may be covalent in nature, may be ionic in nature, or maybe and weak chemical interaction also. But if the molecules or atoms are held to the surface of solid by chemical bond, then such an adsorption will be called as chemisorption or chemical adsorption. So these are the two different types of adsorption we are going to be talking about. And since chemisorption involves the formation of a chemical bond, it will be involving a high activation energy, because every chemical reaction will have an activation energy requirement, and the substances, they have to be activated, they have to be given some energy for them to reach the activation stage, and hence the chemical adsorption or chemisorption is also called as activated absorption. So when you hear the word activated absorption, don't get confused, it is nothing but the chemical adsorption or the chemisorption. And to make this happen, the temperature has to be generally high for the chemisorption to begin, because the particles need to reach their activation energy level. And sometimes what we see is if we have a surface which is the adsorbent surface, and if we have adsorbate, then there can be both the phenomena happening. So at low temperature we may see that physical adsorption is happening, and as we increase the temperature we may even see that the chemisorption will begin. But the chemisorption will be highly selective. We cannot have chemisorption occurring between any and every substance, because we're talking about a chemical bond formation. So we can divide the adsorption into two types: physical adsorption and chemical adsorption. Chemical adsorption is going to be specific because we are talking about the chemical bond formation, and this requires activation energy, so can only happen at high temperatures. And we can also call the chemisorption as the activated absorption, because we need to activate the molecules to get adsorbed. And for some cases where both the phenomena can occur, initially we'll see that it is going to be the physical adsorption, low temperatures, and as we go to high temperature, the adsorption phenomena will change from physical adsorption to chemical adsorption. But here we need to highlight one thing, that if we increase the temperature really high, then the extent of adsorption, which we will look as the amount of the substance that is getting accumulated on the surface of the adsorbent, the extent of adsorption is going to be decreasing. So since these are exothermic process, delta H is negative. So remember, in the equilibrium we talked about the Le-Chatelier principles. For whichever process the delta H negative exothermic process, if we increase the temperature, then the process would be going in the reverse direction. For the endothermic process, where delta H will be positive, increased temperature means the process will be going in the forward. For the exothermic, delta H negative, increasing temperature means the process will go in the reverse direction. So as such, temperature is not favorable, high temperatures are not favorable for any adsorption, whether it is the physical adsorption or the chemical adsorption. But if we talk about the temperature needed to begin, the chemisorption can only start after some high temperature level. Before that, the chemisorption can never happen, as we require to have the activation energy. So we'll talk about this when we go to the difference between physical adsorption and chemical adsorption. So this is about the two types of adsorption we can have. And coming to the fundamental differences between the two, if you look at the physical adsorption, which is happening because of the physical force of attraction, which we also call as the van der Waals force of attraction. They are generic forces between any two substances. The heat of adsorption will be usually in the low rate. It will be in the range of 20 to 40 kilojoule per mole. Whereas if you look at the chemisorption, since there is an involvement of a chemical bond formation, it will be high. It will be in the range of 50 to 400 kilojoule per mole. And the reason for the physical adsorption is van der Waals forces, which will be weak forces. And in case of chemical adsorption, it is the chemical bond formation that is the reason for the chemisorption. Physisorption is easily reversible. Once we have the particles that are getting accumulated, and remember, in case of physisorption, we can have multiple layers. That's why we also call it as a multi-layer phenomena. So as the particles are getting accumulated, if we increase the temperature, you know what will happen? The particles will again release off from the surface. So this is easily reversible. Whereas the chemical adsorption or chemisorption, which is going to be a monolayer concept, because once a layer of chemical bonds are formed, then there is not going to be another chance for next layer of particles to come, because they cannot form a bond with the surface of the adsorbent. So it's going to be just monolayer or a single layer phenomena, the chemical adsorption. So once the bond is formed, you will not be able to easily reverse it. So physical adsorption easily reversible, chemical adsorption it is difficult to reverse it. And physisorption, it takes usually at the low temperature, because if you increase the temperature, the energy of the particles will increase, then the particles will be moving away from the surface. Whereas the chemical adsorption also, if we raise the temperature too high, then again, since it is also a delta H negative process, negative enthalpy change process, high temperature will not be favorable. But the chemisorption will begin itself at high temperature. Low temperatures, chemisorption will not happen. And we can just look at the physisorption as the liquefaction of a gas. So gas particles getting condensed on the surface of a solid or a liquid. So that is how we can look at the the physisorption. But the chemisorption, we will not be able to relate to any physical phenomena. This is more in terms of the chemical interaction between the adsorbate particles and adsorbent particles. We talked about the layers. Physical adsorption, we can have multiple layers, and chemisorption will be a monolayer phenomena. And physisorption, it does not require any activation energy because there is no formation of a chemical bond, and chemisorption requires activation energy. Generally, in terms of pressure, both of them If the pressure is high, what essentially happens is if you have the high pressure, then the gas particles will be pressed towards the surface of the metal. So high pressure will be a favorable condition for both physics absorption as well as chemical adsorption. But if we decrease the pressure, what happens is the adsorbed gas particles will go away because it is easily reversible in case of the physical adsorption. So we'll see that decrease of pressure will cause a desorption. We talked about it. Desorption is a reverse process. The already adsorbed particles, they going away will be called as a desorption. But in case of the chemisorption, decrease of pressure does not easily cause desorption. Why? Because there is a chemical bond formation that has already happened. So just because we decrease the pressure, now these particles will not be able to easily break the chemical bond and go away. So that is the difference between the physisorption and chemisorption. And the last and important one is the physisorption can happen between any two substances. Any gas can get physically adsorbed onto the surface of any solid, but the chemisorption is very selective. We look at the examples of it. So most of the gases they get adsorbed on the surface of the charcoal. Now adsorption of nitrogen gas on mica, so all of them are the examples of the physical adsorption. Chemisorption, if you look at the ethyl alcohol vapors getting condensed on the finely divided nickel, that's a chemisorption. Adsorption of oxygen gas and tungsten, adsorption of hydrogen and nickel, so all these are actually the examples of the chemisorption. So where there is a chemical interaction involved between the adsorbed particles and adsorbent particles. So this is about the types of adsorption. Now in the next video we'll look at the applications of adsorption.